How's it going, everybody? Today we are going to look at fractions. So fractions can be a very difficult topic, believe it or not, especially when we start looking at adding and subtracting, which we're going to do today. There's really no way to sugarcoat the process of adding and subtracting fractions, but I am going to show you some really good techniques. You have to be very careful in how you find common denominators, reducing. It almost seems like it's an endless process. But if you take your time, it actually becomes not too bad. All right, you just gotta make sure that you're following all the procedures. I'm gonna give you like somewhat of a flow chart that I've used when I taught adult education. And as long as you're following the procedures and all that, you should be okay. And the subtraction, ironically enough, is actually the hardest of the four operations. But we're gonna go through it, something that you can use as a tool, go back and watch multiple times. You should find it useful, all right? All right, the first thing I want to provide here is a bit of a flow chart that I used to use with my adult students to help you go through the process of adding fractions. So when you're adding your fractions, I typically like to have the fractions on top of each other vertically. Some kids like to use them side by side, but you can go either way. But I find that if you have them stacked on top of one another, especially when you get to subtractions, it's much easier to show the work and do the work. So the first thing you want to ask yourself is, do you have a common denominator? And at this point, you should know that the denominator is your bottom number. So having the denominator being the same number basically tells us that they're compatible, so to speak, and that you can go ahead and add. So if you don't, you want to find a common denominator, which we're going to discuss as we see some of these problems. If you do, you keep the denominators the same, but only add the numerators. If they're not, you're going to find a common denominator, and then once you do that, you can go over here to this step right here, and then once you've done the adding, you want to simplify or reduce, which we'll look at as well. Now, in the case that there's a whole number, which means if there's a whole number, like for instance this, 11.5, this is considered a mixed number. There's a whole number here and a fraction here. This makes this a mixed number. But you would add the fraction portions together first, and then the whole numbers. All right, as you can see, I have these fractions stacked. All right, the first one is just dealing with fractions, proper fractions, and then the one over here is dealing with mixed numbers. So we don't have a common denominator right now, so we're going to look for one. So what I suggest is this. We notice that this is the larger of the two denominators. So we're going to take our multiples of 12. Well, we know that 5 can't go into 12, but 12 times 2 is 24. We ask ourselves, can we multiply something by 5 to get 24? No. Then 12 times 3 is 36. Can we multiply something by 5 to get 36? No, we can't. 12 times 4 is 48. Can we multiply something by 5 to get 48? No. Then 12 times 5, ironically enough, is 60, right? And that should work because we're actually using 5. So 60 is going to be our common denominator here. All right, so we're going to use 60. All right, so let's take a look. 60 is going to be our common denominator, so we'll write 60 underneath here for both because we know that's going to change. Then we go back and ask ourselves, well, what was it that we multiplied 12 by to get 60? 5. You do the same to the top. Remember, math is all checks and balances. We multiplied 5 by 12, so we multiply the top by 12, we get 36. Now, as I said in before with the flow chart, the denominators stay the same. That's just showing that they're compatible. But you get 60, and then 55 plus 36 is 91. Now, if you don't know already, this is considered an improper fraction, all right? The reason it's improper is that I tell the kids that the top portion, the numerator, is actually larger than the bottom. It's like too heavy. So you're going to divide the bottom into the top. 60 goes on the outside, the denominator goes on the outside. It goes in once. We get 31 left over, but we're not writing that as a remainder. That's our new numerator, and then we have 60. And then you want to look to see if you can reduce, but you can't. So our final answer would be 1 and 31 over 60. Now this one over here on the right is different because we have mixed numbers, which is a whole number paired up with a fraction. So we're going to look to see what our common denominator is. Nothing happens with the whole numbers. We can just slide those over. Let's do the same process. 10. Well, can 6 go into 10 evenly? Notice I'm using the bigger of the two. No, the 6 cannot be multiplied by anything to get 10. 10 times 2 is 20. Can you multiply something by 20 or by 6 by something to get 20? No. 30. Can you multiply something by 6 to get 30? Yes, you can. All right, so we're going to use 30. Now, sometimes I find students will just multiply the two denominators together, and that will work, but you end up with these super huge fractions sometimes, which you don't really want, because then you're going to have to do all this crazy reducing at the end. So we try to avoid that. We go through. What was it that we multiplied 6 by to get 30? 5. 5 times 5 is 25. What do we multiply 10 by to get 30? Well, 3. 3 times 3 is 9. Now, we're going to go ahead and add these. We can do the whole numbers. 4 and 2 is 6. 9 and 25 is 34 over 30. All right, same situation as before. We have an improper fraction here. So we're going to divide 30 into 34. So 30 goes into 34 once. We subtract, we get 4 over 30. This can be reduced. So we have 1 and 2 over 15. We're reducing by 2. But here's the issue. What happens with this 6? Well, we're just going to marry these two together. 6 and 1 is 7. So you have 7 and 2/15 as your final answer. So you can see, face value, all these look fairly easy, but it's actually a lot of work in some cases, all right? Especially if you're not using a calculator, which, I try not to do. All right, here is our flow chart for subtracting fractions. So first thing you want to ask yourself again is, do you have a common denominator? If not, you're going to go find a common denominator. If you do, then you got to ask yourself, is the numerator larger than is the numerator on top larger than the numerator on the bottom? If it's not, you're going to have to borrow from the whole number. Now, there's no way that, at least for what we're dealing with right now, that if you don't have a whole number, that the numerator on the top is going to be smaller than the bottom, because that's dealing with subtracting or integers. So we probably won't see that just yet. So then what you're going to do is borrow if you need to, subtract, and as always, look to see if you can reduce. So let's take a look at some of those types of problems. All right, let's take a look at this problem here on the left. We have 9 3/5 minus 1/4. So do we have a common denominator? No, not yet. So once again, we go 5. We'll go with the larger number. 5. Nope, 4 cannot go into 5 evenly. 10. 4 cannot go into 10 evenly. 15. Nope, 4 cannot go into that. 20, yes, 20 will be our common denominator. So let's throw those guys in. We can bring the 9 and 1 over just like we did with adding, because we don't know if we're going to borrow yet. So what was it times 4 that got us 20? Well, that was 5. 5 times 1 is 5. What was it times 5 that got us 20? Well, that was 4. 4 times 3 is 12. Now, the next question we want to ask is, do we need to borrow? Well, the 12 is larger than the 5, so there's no reason to borrow. So 12 minus 5 is 7 over 20. And then we do the whole numbers. It's almost like it's two separate subtraction problems in one here. So 9 minus 1 is 8. We look to see if we can reduce, and lucky for us, we are done. All right, the one on the right. So once again, we do not have a common denominator as of yet. Start with the larger denominator, 3. 2 cannot go into 3 evenly, but 6 will work. So we're going to go with 6. All right, once again, we'll bring the whole numbers over. What was it times 3 that got us 6? Well, 2. 2 times 1 is 2. Was it times 2 that got us the 6, which is 3? All right, so then we have 3 times 1. Now, here's the issue. We have a number on top here that is smaller than the number on the bottom. So we're going to borrow from this 8, which makes this a 7. All right, now you're simply going to add these two together, 6 and 2. That gives us an 8 over 6, which looks really weird right now. This is where kids get nervous. But we're not finished the problem yet. So then we have 2 and 3, 6. We're going to subtract. We end up getting 8 minus 3 is 5. And then 7 minus 2 is 5 as well. So we have 5 and 5, 6. Now what I will do is show you another way that some kids like to do. So we're going to pick it up right from here. Right from our common denominators. No reason to do that over again. So we have 8 and 2, 6. 2 and 3, 6. Now what some kids like to do is that they're going to make these improper fractions. So we do 8 times 6 is 48 plus the 2. So we get 50 over 6. And then 6 times 2
is 12, plus the 3 is 15 over 6. All right, so we're gonna subtract here. And I know it looks like mixed numbers, but that's okay. 50 minus 15 is 35 over 6. We're gonna fix this. 6 goes into 35 5 times. And you notice that we get 5 and 5, 6, just like we got up here. Now the method I always stuck with in school was this top one, but I'm finding that some kids prefer this. It's all about how they're taught. So if you're a parent looking at this, know that both ways can work. It's just a matter of the student's preference.
Oh, what's up, guys? Just working on my TikTok here, but I'll get to that later. So that was our video on adding and subtracting fractions. You can see that there's a lot of work involved. I gave you a couple different methods. Make sure that you are taking your time with it, because it's definitely laying the groundwork for things that you're going to see later on with solving one-step, multiple-step equations with fractions. So you got to have this hammered down in order to be successful at that. So I hope it was useful. Please make sure that you subscribe. It'll help me out. Otherwise, have a great day.